Okay, so today we are going to talk about, finish talking about radicals, simplifying them, and converting them to rational exponents. So we have to keep in mind that, remember, we talked about restricting our domain to x is greater than 0, and now we know the reason we're restricting it is because we don't want any negative values under our radical, because if they're negative, we figured out that we really can't take the square root or fourth root or sixth root of that number. Okay, so let's go to the next page. Okay. And we're going to talk about going from rational exponent to radical form. So this would be radical form because it obviously has a radical. When we convert it to power form, we put the exponent that's on the outside. So in this case, it's a 1 because it's to the first power. When we convert it to exponential form, you keep your base, so we keep x, and then our power becomes our numerator, and then the index becomes our denominator. So this is what's called exponential form, because you are writing the radical in terms of an exponent. So when you're thinking about a cube root, let's talk about restrictions. So the cube root, they can have negatives, so this would be all real numbers. Okay, all right, let's go to the next one. So this one, they gave us exponential form. So this 3 is our index. Okay, so I know that it's going to be, if I come over to radical form, I know it's going to be a cube root. And then this 2 is our exponent, so it's going to be x squared. If I write it in power form, all that means is that it doesn't matter if the squared is on the inside or if I take the whole thing to the second power. Okay, so this is power form, this is exponential form. So since this is a cube root, again, I'm looking at all real numbers because I can have negatives in my radical. Okay, so now we've got a fourth root. So let's think of the power form. So that's a fourth root x to the third. So our power is our numerator. Our fourth root is going to be our our denominator. So we've got x to the 3/4. Okay. Now since this is an even radical, we're going to restrict our domain to numbers greater than or equal to 0. Okay, and last one. So this would be the square root of x to the 6. So since it's a square root, we're restricting our domain. And then when we convert it, it would be x to the 6/2, because 6 is our power, 2 is our index. But if you think about that, you can reduce this. 6 divided by 2 is actually 3, okay? And which is something that we're going to look at a little bit later. Okay. All right, so let's put these to practice. So we are going to rewrite the expression using rational exponents, okay? So that's exponential form. So right here, each one keeps the power it has. So for example, y has a first power, and I'm going to rewrite it with 3 being my index. So it's x 4 over 3, y 1 over 3, and then z 9 over 3. And then if I can reduce, but we'll reduce later. So we're going to leave it in rational form here. Okay, so next one. So this is the same. So everything is in the fourth root. So my index is 4, and this has a 1. So I'm going to keep the fraction. So this is a to the 1/4, b to the 5/4, and then on the bottom, on the denominator, c to the 3/4. Okay, all right, let's try going the other way. So now going the other way, this would be my exponent, and this is going to be my index. And this whole thing is going to go under a radical. So I've got x plus y. So 5 will be my exponent, and then it'll be a fourth root for my index. Okay? So right here, if you notice, this doesn't have an exponent. So, well, I mean, it has an exponent, it's a 1, but I want to keep it consistent with the others, so I want my index to be 3. So what numerator can I give this so that when I simplify it, I get 1? Well, 3 divided by 3 is 1, so I'm going to make that a 3. So now, all of this is, since they all have the same denominator, they're all going to go under the same radical. A will be to the power of 1. B will be to the fourth power, and then C will be to the third power. Okay, all right, so why don't you take a look at the self-check, and I'll pause here for a minute, and you go ahead and see if you can figure out if they're true or false. Okay, so here are my answers. This one is false because the index should be the denominator, and the power should be the numerator. This one is true. That's my index, that's my power. And then the last one is false because this, we can't have negative numbers, so our restrictions would be x is greater than or equal to 1. Okay, so now we are going to start simplifying. Okay. So when we simplify, we are extracting roots, and then we're going to rewrite the variables. So when you think about this, when we simplified square roots, we were looking for perfect squares. So when we're looking for cube roots or fourth roots, we are looking for perfect cubes, if you will. So let's put a little list of our perfect cubes down the side here. So we've got, well, let's do squares. No, we'll do cubes. So let's do cubes. So think about 3 to the first power is 3. 3 to the second power is, no, sorry, I'm reversing this. So it's 1 to the third power is 1. 2 to the third power, so that's 2 times 2 is 4 times 2 is 8. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power is 243. And let's just go one more. 3 to the sixth power is 729. So they get pretty big pretty fast. Okay, so let's take a look at simplifying. So if you remember, we would rewrite these in terms of perfect cubes or perfect squares or whatnot. So since this is a cube root, I'm looking for the biggest perfect cube that divides into it. Well, obviously 8. So this is the same as the cube root of 2 to the third, because that's 8, and then times the cube root of x to the sixth. So this, like we talked about yesterday, the index and the power are inverses of each other. So this ends up as just 2. And then you have to think about the power here. So you could rewrite it as x and then 6 over 3, which then simplifies to x squared. Or you could think about if you have 6 x's and you need to make groups of 3, how many groups will you have? You'll have 2, and nobody will be left out. Okay, so now let's take a look at this one. So no numbers, and it's a fourth root, so I don't have to worry about listing my fourth roots, or my to the fourth power. So let's look at f to the 8. So I can rewrite these. I can say, well, this is f 8 divided by 4, and g 4 divided by 4, and then simplify it from there. So squared and 1. Or you could think about the powers and say, all right, you have 8 f's, and you need to make groups of 4. How many groups of 4 can you make? 2. Great. So f squared, nobody's left out. Then for G, you would say, okay, I have 4 people. I want groups of 4. Well, there'll be one group. Okay. All right, let's try another. All right, so here, a little bit different because you've got to the 4th power. So the thing is, if you have 4 x's, you can make one group of 3, but then somebody is left out. So I can make one group, so x to the 1st, but then that one person is going to have to stay inside. And then if I have 2 y's, nobody can make a group, so that's not going to change, it's going to stay. Then for the z's, you have 7 z's, you want groups of 3, so let's see, I can make 2 groups because that's 6 people, so that's 6 people, and then there's one person who isn't in a group. So there's my reduced form. Okay, over here, so we've got a 4th root, so let's make a list of some. So 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, so right there's our winner. So this is the 4th root of 3 to the 4th, and then let's just separate our variables and we'll deal with those kind of separately. So these are inverses of each other, so I know I'm going to have a 3. And then here I have 5 x's, I want a group of 4. Well, I can make one group, but then there's one that just isn't going to be a part of the group, so that's going to stay. If I have 12 y's and I want groups of 4, I will have 3 groups. Okay, so that's a simplified version. Try another. Okay, so this one, this whole thing is to the 9th power. And so if you wanted to rewrite it, it would be 9 to the 3rd, which reduces to 3. Okay. Or you could think about, you have 9 groups, or 9 people. How many groups of 3 can you make? Okay, one more. So this one is an index of 2. Well, just looking at this, the square root of 81 is 9. And then I have 6 x's. I want to make groups of 2, so that's 3 groups. Nobody's left out. Not enough y's. The z's, I have 3. I want to make groups of 2, so there's at least one group of z's, and then one that's left out. Okay. All right, so for these next 2, why don't you give them a try? I'm going to pause it, and then I'll show you my answers. Okay, so here's my answers. So this one, 9 groups. I have 9 of these, and I want groups of 3, so I can make 3 groups. So there's my answer. This one was a little bit tricky because with the 256, I had to kind of think about what it would be. And I know that 2 to the 8th power is 256, and so when I bring it into the radical, I can separate it like this and say, well, I can have, this would be 2, 8 to the 4, over 4, which is 2 squared, which is 4. So that's where 4 came from. And then the x's, I could make one group, 2 were left, and then the y's, I could make 2 groups. Okay, so now your homework is 1 through 11 odds, so I would get started on that. Unless you have any questions, you can ask, but now would be a good time to work on the homework so that you can ask questions.